On GMAT Data Insights, one of the easiest ways to lose points is to assume that a graph works the way graphs usually work. But sometimes the graph is scaled or organized in an unusual way. And if you don't notice that before you answer, you could fall right into the trap. So here's a good example. Pause the video if you want to give it a try. But before we answer the questions, we need to understand how the graph is set up. First, notice that the temperature is higher on the left. That's unusual. Most graphs increase from left to right, but this one doesn't. Second, notice the scale. The temperature axis does not increase by equal amounts. It doubles at each major mark: 2,500, 5,000, 10,000, 20,000, and 40,000. So equal distance on the graph does not mean equal change in temperature. The luminosity axis is even more extreme. It increases by powers of 100. So this is not a graph you want to read casually. Now let's look at the first question. It asks, which group of stars the sun must belong to? The key is that luminosity is measured relative to the sun. So the luminosity of the sun is 1L sun. Looking at the graph, the only group with stars at a luminosity of 1L sun is the main sequence. So the sun must be a main sequence star. Now you may already know that from science class, but on the GMAT, you generally do not want to rely on outside knowledge. The question gives you enough information to solve from the graph. Now let's look at the second question. We want the group of stars other than the main sequence with the greatest range of temperatures. If you just eyeball the graph, you might think the answer is red giants. Visually, that group looks pretty spread out. But remember the temperature axis. Because the scale is unusual, visual width does not directly tell us the actual temperature range. So the red giants are between the 2,500 and 10,000 marks. So their temperature range must be less than 7,500 kelvins. Now look at the white dwarfs. They stretch from a little under 20,000 kelvins to almost 40,000 kelvins. We may not know the exact endpoints, but we don't need to. That range is clearly more than 10,000 kelvins. So the white dwarfs have a greater temperature range than the red giants. They also clearly have a greater range than the blue giants and the red supergiants. So the answer is white dwarfs. The big lesson on Data Insights: don't just look at the data. Make sure you understand how the data is being presented. Read the title, the labels, the legend, the axis titles, the scale, and any notes in the question. Here the trap is that the temperature axis runs in an unusual direction and uses an unusual scale. If you miss that, the graph is easy to misread. So hopefully that helps the GMAT make sense. For more quant data insight tips, check out my free study reset at the link in the description.